Hello everybody and welcome back. So in this next lesson we're going to be diving into an example just to kind of use everything we've used up to this point, but particularly focused on the geometry side of Python. So using Python SOP and then also using some of the on-the-go stuff that we've used up till now, but actually referring to the geometry class, but we also use a few parameters and nodes as well. All right, now this example is something that actually I have literally come across in my career. So this is something that I've had to literally do almost step for step, and I thought it was a perfect example of how Python can take something that would literally have been incredibly difficult and mundane without it, and yet with it is really fast, and it's also reusable. So it could be done not only on one model, but it could be done again and again and again, right? And in fact, in this particular case, it has been reused many times. So basically what happened is we were working on an advertisement, and in the ad, it had a sort of a little village at, obviously like sort of winter time, Christmas time, whatever. And then in the shop window, there is obviously, a bunch of decorations, and one of them being a Christmas tree. So I've made a model here of a Christmas tree, very rough, not a very good one, but just a rough approximation of what I was given. Because what we wanted to do with this was basically the lighting lead wanted to actually put lights, like real Houdini point lights, inside of every one of the tiny little lights on this tree. Okay, so he didn't want to do it with emission. He actually literally wanted control over actual realistic lights in this tree, because we had some real close-ups as well. It was turning out to be much harder to sort of fake than it was worth. So he asked me, can you write something where we can just have actual lights placed in each of these in these tiny little Christmas lights. Okay, and he also wanted them to obviously be colored the same color as the light is, rather than having a white light inside and then relying on it refracting correctly with the color. It was just easier to have an actual, do a light pass where you just have these lights casting light on the tree, and you'd ignore the actual light bulb itself. And then in addition to that, we need control over because if we're going to create, I can't remember how many I've got on here. I think maybe about 500 or 100 lights at the moment, but in the end, I think there were 1,000. I've just reduced this so that it's a little bit easier to manage. But you want to now, once you've placed those actual lights, if they're actual point lights in your scene, then, can you imagine? Okay, one is fine and changing the intensity, but can you imagine having hundreds of these, and now you have to go and change all their intensities, or go and drag select them and change it like this, but then hope that you've managed to select them all. And it's also very difficult to manage like this. So we're going to put this in a subnet, so make sure that these are all encased in a nice neat subnet full of lights. We're going to make sure that there's a control that can control some of the key parameters of all of these lights combined. So stuff like intensity, exposure, maybe just enabling and disabling the light. And also we're going to put the shadow mask as one of those shared parameters as well. I've just picked a few parameters that we're going to do. You can obviously do it to whichever you want, or you could do it to every single parameter on here. So we're going to do that. And then also we want, just so that it's easier to work with, don't underestimate user friendliness when you're working with Python. Sometimes it can be a little bit pedantic. It depends on if you're creating a tool that you're going to sell or put online and have other people use it that have never met you and are not in the same studio, that needs to be very robust and obviously very user friendly. But then there's this tendency within a studio to be like, well, you know, it's just a quick tool to achieve a quick result. But you've got to think of how that person's working with it every single day. And one of the problems here is that with these lights, no matter what color we set it, the actual icon doesn't change color. But it's much easier if all of these had the same color as the actual light that they are, because then you could go through and click on, you know, select all the red ones and select all the blue ones or whatever and do something to them, or, you know, something like that. It becomes easier to kind of manage it and work with it. And also don't forget that look how big these icons are, so it would be worth actually scaling down the icon when we do it to something that's a little bit more manageable. So everything I've just listed is kind of our task now. These are all the things that we're trying to achieve, okay? And I'm going to encourage you throughout this exercise. I may try and remind you, if I remember to remind you, but what I suggest you try and do is, once I give you this sort of brief of what we're going to aim for, try to go and do it yourself first before you actually follow this example. And then, you know, and then maybe follow along a few stages and see kind of which direction I've gone, and then stop at a certain point and then take that base that I've worked with and then try and take it further and see if you can complete it, and then come back and continue the lesson. That's going to be the best way for you to get the most out of this lesson and this example, is to essentially see if you can apply it yourself, or see if you can think logically through the system, but then obviously come back and see how I've done it. And then maybe if your system didn't work or whatever, you can kind of follow me halfway and then stop again and then see, okay, well, you've followed half of it, now can you complete the rest, and so on. Right? So please try do that just for your own sake. You can obviously just put this on, follow along, and then be done with it, but there's a good chance that you're just going to forget that. And I want you to walk away not with information and knowledge about Python. I want you to walk away with actual embedded skills. All right. So one of the first things we're going to need to do in order to achieve this is to work with the geometry. And I've very specifically set up this model in a way that I was given it on this project, because sometimes you get models and it's not perfect. The geometry is not ideal for you to do something. You know, it would be great if all of these bulbs were packed separately, but then, so like each individual bulb was packed, and then all the bulbs were packed together as one sort of light thing, or put in a group or something, so we can work with it. Now, I've obviously done sort of some of that, but there's a very specific problem with the bulbs and the way that it's packed, so I'll show you. And we do come across this quite often, which is why you sometimes need to be able to work with it. Obviously, if you can go back to the person who modeled it and just ask them to group it differently or pack it differently, and it's an easy change, then go for it. You know, don't make it harder for yourself. But sometimes that's not possible. Maybe you've bought the model off of online, you know, like some kind of stock website or whatever, and then you just have to deal with what you've got. Okay, so let's take a look at this geometry. So what I'm going to do is I'm going to put down another geometry node. So I've got my model loaded in here, and by the way, it is just a BGO. I will provide this to you guys. I will also give you the scene where I built this, just so you can see what I did in there. I didn't use any Python in there. It was just some normal Houdini tricks. But yeah, it's all in there in case you want to mess around with it as well. So I'll give you that, and I'll give you the BGO. But yeah, we're basically going to just work with this. But you can apply this to anything you want. Okay. So first thing we're going to do is obviously just import that geometry. So we want to work in our separate thing here. Let's call this light. So I'm going to call it light source, because what I really want to do is I want to pull apart this geometry and create a single point at the center of every bulb, so that I have a very specific point to kind of copy these lights onto, right? But there is no way to sort of just do copy, like when you do copy to points, you can't copy lights to points, right? They're separate objects that, at OBJ level, they're not SOPs, okay? They're not geometry. So we can't do it that way. And sure, you could copy geometry and create a geometry light out of all of it, but geometry lights are, they're great, but they tend to need a lot of samples, and to have this much geometry as a geometry light, all tiny little separate things, very, very tricky. Okay. Plus you'd also have to separate it into colors. So what we're going to do is just keep it really simple and put a point light at each one of them. So we're going to have to create our own way of copying that onto every point. Okay. But the first step is to get that point. And then in addition to having a point at the center of every bulb, we also need that point to know what color it should be, because our copy system is going to need to read that color attribute. Okay. So let's do this step by step, right? But I have just explained what we need out of this. So you're welcome to try and see if you can achieve that. So pause the video now, go see if you can achieve that first on your own, and then come and see how I achieve it. Okay, so let's dive inside here. So I'm going to import the geometry. So there we go, it's in my tree asset, and it's called, I've created an out in there. You should always create nulls with an out or something descriptive. Okay, all right, and let's look at what we have here. So we have 5 points, 5 primitives, 5 vertices. So it's 5 packed geometry, right? So it creates 1 for each. We have a color attribute, obviously, because everything has color, and point position, and then we've got path because it's packed. And then we do have some groups here. We've got a group which has 1 primitive in it, which is the baubles, right? We've got lights, that's great. We've got a group with our lights. We've got the star on top, and then we've got the tinsel, okay? And then obviously the tree itself is not in a group, but that's fine because everything else is. So we should be able to work with this. Primarily, we just need the lights, right? And then this is all packed. So the first thing we're going to do is just isolate the lights, okay? Because we know that's what we're wanting to work with. So let's go and we'll delete lights, but then say delete non-selected. So now we keep just these lights. Now something you're going to notice here, let me try and just zoom in here nicely so you can see what we're working with. And in fact, I'm going to go and change my background to a light just so you can see a little bit better what we're doing. Okay, and then also let's go and set my clipping plane to match 0.01, just so that we don't, as we zoom in, we don't lose it. Okay, there we are. So we have the bulbs, but we also have the little thing on the back. Now, in this case, we don't actually even have the wires connecting them all. And I mean, obviously it depends on how close you're going to get to these lights, whether they would have modeled it with actual cables sort of joining them all. So let's unpack this, because we need to see what we're working with inside of this packed geometry. And all the lights are in one big packed thing. They're not individually packed. So we can't loop through all of the sort of packed lights. We need to unpack the single packed object. Now when we unpack it here, unfortunately it is not double packed. Okay, so it's not also now packed with each individual bulb as its own packed item, or alternatively all of the bases packed as one and then the bulbs packed as another. That would have been great, but no. It's all just loose geometry. Okay, now that's not impossible for us to work with, but as I said, if you could go back to your modeling department and say, hey guys, do you mind just packing this differently for me? It could save you a lot of time. In this case, though, I wasn't able to do that, so let's continue with doing exactly what I had to do on that project. Okay, so let's middle click and have a look at what we've got. So we've got color, we've got some normals, point position, and then everything is just all unpacked loose geometry that we don't even have polygon soups. So it's not like we have all of our points, but then our primitives, we've got like only I don't know, 500, or I can't remember how many lights there are. So it's very unfortunate. But what we're going to do is, you see that, like, well, what you're going to do is assess what you have to work with and find a way to differentiate between these things, okay? And often talking it out to yourself helps you do that. So if we look at this, say, well, I want to delete all the things that are black, you know, or very dark, whatever this color is, right? Like, because all the lights, no matter what color they are very, very bright, okay? So it could be white, it could be green, red, or whatever, but they have, you know, high lightness values, although their RGB might be all over the place, because we can't rely on just having an extreme difference in RGB. So in other words, saturation, because this is saturated, but our white lights are not, okay? So we want to use something like lightness maybe, because this is light, this is not, this is light, this is not, okay? Now I also considered using the number of points, and there are a different number of points if we had to sort of go and, let's say, isolate this. So I'm going to delete our one base, and then I'm also going to go delete one bulb and just separate it here. And we can have a look and go, okay, there's 266 points in here and 194 in there. So if we could loop through all the sort of connected geometry, then we could use number of points as a way to isolate the difference between a base and a bulb. That is predicated on the assumption that all the bases and all the bulbs are modeled identically and then just copied. Now that is a safe assumption, because that is generally what's going to happen. Normally they're not going to model each bulb individually. However, at the time when I did this, and I still stand by it, I do not trust geometry to not change. Depends on the project setup, but if you do have an actual modeling department that is creating this model, we had very many times late on in the production, we've already designed the whole system, we're working with it, we're about to render basically, and then the modeling department goes and adds something and changes the geometry, adds an extra edge loop, because in the close-ups it wasn't really holding up, or you know, it was looking a bit odd, so they go and add some geometry, and now our entire system falls apart because they added geometry. Now you could argue that, well, they could change the color later on as well, and they could, but you basically got to decide which thing you think is going to stay the most consistent for your purposes. And in this case, I thought, okay, you know what, color is probably going to be the way that I'm going to divide this, because even if they add geometry, the odds are they want the base to be this dark color, and even if it increased slightly, I'm not going to rely on it being an identical color, a very specific, you know, if we come to our base here and have a look at our color values, I'm not going to put in this exact number. I'm going to just set a threshold that divides the difference between dark and light. And so hopefully, even if they alter the color slightly, it won't quite mess things up. Okay, so that's what we're going to try and do. So now the first thing we can do is very easily, just with a few SOPs, we can find connected geometry, because we need to work with some sort of poly soups, and we don't have that already. Now there's no reason to do this in Python, because there's already some easy Houdini nodes that do this for us. So we're going to use the connectivity node, which does exactly that. It looks for all connected geometry and gives it an attribute called class, or we can call it whatever we want. And because we want to create poly soups, because what we're going to do is we're going to use this poly soup node. But the poly soup node relies on an attribute to tell it which polygons need to be joined into one primitive. Okay, so we need that attribute to be on primitive level. So we're going to change our connectivity type to primitive. And then when we plug in our poly soup, you'll see that when I middle click here, we're going to have 776 primitives. So the base here is now one primitive, that's one primitive, 1, 1. So, and that's because these are connected, but the bulb is not actually connected to the to the base. They are freestanding. You know, this is an enclosed piece of geometry and does not, just because they actually look like they're connected and touching each other, they are not geometrically connected. Okay, so that was a kind of a little hack to just get some polygon soups, because now when I loop over it, if I loop over primitives, I'm only having to loop over 776 primitives instead of 195,000. Okay, and then also if I'm going to do anything to one piece, I need to then find out which things are connected and do the same thing to it. It's much easier to do it this way. Okay, so now that we have our polygon soups, we can jump into Python and use Python to essentially go through all these 776 items, find out which ones are bases and get rid of them, and find out which ones are bulbs and create a point at the center, but inherit the color from the bulb, because we don't want to keep the bulb, we just want that point, but then we lose our color, so we're going to make sure color comes with it. Now we could go do this ourselves, but that would be a real pain. You'd have to go and now delete that and delete and go and, you know, literally go and get rid of every single base. So especially 776 times, I really don't feel like spending my morning doing that. But what's worse is that this was just a simplified example. Really, in the final one, like in the project that I did, it was a couple of thousand. So really not ideal. Okay, so let's jump in and do this. So I'm going to drop down a Python sup, because we want to loop through this geometry and then create some geometry of our own. Now at the end of the day, I don't want the base or the light bulb to come with. I really just want a point at the center. So I'm going to actually plug the polygon soup here into our second input. I want to reference our geometry, but I actually don't want anything to begin with. And I'm going to build up points based on our reference. Okay. Now, again, I'm going to remind everyone, if you feel comfortable with Python now or starting to get a bit better at it, I'd encourage you to stop at this point, stop the video, and go and see if you can write the code. So as long as you've got the same base setup as me, then if you go and write the code, let's see if you're able to get a point at the center of every bulb that has inherited the color of that bulb. Okay, and then come back and try and follow with. All right. So at the top here, we have some important variables that we need to get started with this. We're using who.pwd to grab our node, so we have a reference to our actual Python SOP, and then we're using our node to grab a reference to our geometry. Okay, but our geometry is nothing; it's empty. But we do need a reference to that because we want to fill that with something. So of course we need to keep geometry. However, we need to also reference our input geometry. So let's create a reference to that. So I'm just gonna, for convenience sake, I'm gonna call it geo1, okay? Because we've got geo, so I'll just create geo1 because it's the one being, it's our first input, so it's 0, 1, 2, 3, okay? So I'm just using the index as that number. You could call it geo2 if you want, because if that makes a lot more logical sense to you, or you could call it something else. And we're going to reference our node, so node dot, but instead of doing geometry, I'm going to use the input geometry function. So this, if we go to our help file, you'll see is basically it's just a Python function on a node that allows us to grab geometry from a set input. Okay, so let me go to the who.node class. I'm just going to bring this up because I know we're going to reference it many times, and I want to show you guys how to always refer back to the help file. You don't need to be brave and pretend like you remember every single function, because nobody does. All right. But anyway, while that loads, we just need a single argument for this, which is to say which input. Okay, so we say input 1, which is this one, so it now grabs a reference to that. Okay. And of course we can, just to double check, we can print geo1, just print geo1, and you'll see here in our little shell, it prints who geometry. So it's a geometry class, and at that location, and it's grabbing the polygon soup one. So right there, it's saying it's grabbing all of that. Okay. Perfect. So that's step one, is just getting all of our references. Now, let's just have a look here if this is loaded. Yes. It always takes a long time to load the first time, and then after that it seems a little bit quicker. So just be patient. At the bottom there's a yellow bar that loads, so just wait for that. So if we look for geometry, sorry, that'll be under our SOP node, don't forget. So our subclass will have the geometry. So there's geometry, but there is also input geometry, and we give it an index. Okay, so this is the one we're using. Right, so let's move on. So now what we want to do is we're going to want to loop through our primitives, because we know we have turned them into polysoup, so we can loop that many times. And for each one of those, we want to do something. Now, what is it that we want to do? Well, we want to say, okay, are you very dark in lightness? If so, like beyond a certain threshold, then, well, we're going to ignore you because you're clearly just the base. You're not an actual light bulb. If you're above a certain point and you're a light bulb, then we're going to find your center, create a point, and set color. Okay, these are the steps we're going to follow. So we're going to go for prim. Okay, I'm just going to call mine prim. You can use like p or whatever variable you want, but I'm going to say for prim in. And now remember, we're looping through our second input, not our base, which has actually nothing in it at the moment. So it's Geo1 that we're looping through. But what do we need to loop through? Remember, Geo1, we just printed it over here. Geo1 is just a single reference to the geometry. We need to grab its primitives. Okay, and if you remember from the last lessons on who.geometry, we'll find that we can grab our primitives. So we need to often move from geometry level to prim or points or whatever. And we'll see that under prim, we have prims. Okay. Now we could use iter prims, but that's only if we wanting to grab a single bit of it. In this case, we want to reference every single primitive, because we're going to loop through each one and we're going to ask it a question, basically. So we do want to do geo.prims. Okay. And let's just double check. I always check. Don't get arrogant and assume that everything is working, because that's when errors happen later and it takes you a lot of time to go back and fix things. So let's print prim and make sure that we actually have all the primitives. Okay. And you'll see here it is printed every single time, and it even tells us our primitive number, and it goes up to 775, which obviously the primitive number starts at 0. So that is perfect. Okay, so now we have all our prims. So oh, and in fact you can also, if you ever want to double check, another way of doing it instead of doing prim is you can do len prims. Not in here, outside here you can do len prims, and you can just kind of double check that it works. Okay, so now what we want to do is check essentially the center point and the color. Okay, now the first step that we're going to do is check the color, because we basically want to say, if you're this really dark thing, then we're going to ignore you entirely. So the very first step is to grab our color attribute. Okay, now to get an attribute, we need to do the it's attrib value. Okay, if you remember this from the last lesson, let's go to prim over here. So under prim there's an attrib value, under point there's an attrib value, under vertex there's an attrib value. Obviously under geometry it's the weird one where it's I think it's global attrib value or something like that. But anyway, now what level is our color actually living on? If we go back to our geometry over here and maybe isolate just one of these, okay, and let's come in and have a look. Now if we look on primitive level, you'll see we only have a class, and that's actually something that we created through our connectivity. Okay, our color lives on point level, and so we're going to need to look at our points to get color. But every point in this entire piece of geometry has the same value. So we don't really need to grab all of the points and loop through them, but grabbing at just one point, 0, whatever, is sufficient. Okay, so let's grab just one point and ask for its color. So I'm going to create a variable where I'm going to store the reference to my point. And now I'm going to go on my primitives. So on prim level, we can run, let's look in here if we have a way to grab, so points. Okay, so we can grab points, and it's going to be a list of who.point, right? Now we don't want to do it from geometry level, even though that gives us access to that iter points, because we don't want to loop through just all the points or grab just one of the points. We want to specifically grab a point within this primitive, because once we find what happens to this, like what the color of this one point is, we're going to apply that result not to the point but the primitive itself. And so we have to do it inside of the primitive loop. Okay. Now according to this on this list, it doesn't have iter points. Sometimes I have found that this help file is a little bit out of date and they haven't added it, so we're going to actually test and see if iter points works. But if iter points doesn't, we can still just use points and grab point 0. Okay, so let's just try it. Iter points and then just grab 0 and see if that works. No. Okay, so there is no iter points for prim. So let's just go and grab points. Okay, so points with no arguments is just going to give us a whole list of the points, but then we just say 0. So give us point 0. Okay, and let's make sure that that has worked. So we're going to say print pt. All right, and now for every single primitive, it goes and prints the point 0. So the first point within that geometry. And you'll see that there's big gaps between the numbers because obviously it's only looking at that one point and then it's moving to the next primitive. So it's skipping a couple of hundred points in between. Now we're going to ask this point, what is your color? What is your color value? So remember, we're now on point level. We've got access to a point. So we go and look at the who.point class, because these are the functions, the methods that we can apply to our point. And we want to, right at the top here, we want to ask it for its attribute value. So pt.attrib value. Okay, and then we just need to give it the name or attrib. In this case, just name, because we know that what we want is CD, which is color. Okay, and we obviously want to store this. Now, I've mentioned this before, but I want to emphasize it now. With color, remember that who.color with a capital C is an actual class. Okay, so who.color. When we grab the attrib value here, this is returning just an actual tuple of our RGB values. But what we want to do is work with that value and grab not RGB, because RGB is not useful to us in this case. Okay, how do you know from RGB whether something is dark or light? Yes, you can kind of look at it. If the values are all really high, then you know that it's very bright. But what if red is 0, but then the other values are really high? Now that's just going to be a very saturated color, but that's not necessarily not a light color. So you have to have all these three values interact with one another. Okay, and it's going to be much easier for us to convert to something like HSV or HSL, so we can check. We can use either L for lightness, so we can use our lightness, or we could use value. Either one of those, it would be worth checking which one gives us the most extreme values. Okay, but in order to run a function like this, like converting our RGB into HSV or HSL, we have to create a reference to a who.color class, and grabbing the attribute value here is not doing that. That is just giving us XYZ, okay, so RG and B. So that's why I've stored it specifically in something called col_val, so the value of the color attribute, as opposed to an actual color reference. I'm going to create another variable called col, where we're going to convert our values, RGB values, into an actual who.color class. Okay, well, an instance of that class. So first of all, again, let's just double check that our color value is working. Okay, and there we go. You see we get a tuple for every single point. Okay, so let's go and now turn this into an actual who.color instance so that we can do stuff to it. So I'm going to call that col, right? So because that is an actual color. So who.color, okay, and remember it is the American spelling for this, and a capital C, because this is not a function that is creating an instance. This is actually, we are actually running the generator. We're running the init function of the color class. Okay, so under who.color, you see that we have this init here, right? We do not have that on who.node, which is why the only way to grab nodes is through another function that references a node that has already been created. Whereas in this case, we actually do have this function that allows us to generate an instance of this class. Okay, and what that init wants is an RGB tuple, so X, Y, or Z, right? But what it also does allow us to do, which this is one of those weird ones where it says what it wants is a tuple, but if you feed it actually 3 separate values, I think it does actually work and gives you a color anyway. So you could just feed it 3 arguments and it treats it as a tuple. But it's probably better to always just give it exactly what it's asking for, and because it specifies it wants a tuple, let's give it a tuple. Okay. Now remember what we just printed out of here is a tuple. So if we just feed that value in, it's going to convert it to a who.color. So we're going to just say col_val. Okay. And again, let's print this. Let's check every time as we work our way through, check that things are working. So now you see we have a who.color, and this is how it represents itself. So its repr function is having it print this thing where it tells us the R, G, and B values, but obviously clamped to certain sort of float value, right? So we successfully have turned it into a who.color instance, right? And the reason we did this was obviously so that we could convert to HSV or HSL, because we want to essentially grab value or lightness. So if we just convert it to HSV, and then in this tuple it's H, so hue, saturation, and value. So we would grab our last index of that tuple. So let's do exactly that, but let's just print it for now to see what we're getting. So we do col dot, and then we go HSV, and it needs no arguments because it's just converting it. Okay, and then let's just print that. So now these 3 values are now not RGB but actually HSV. Okay, now hue, it'll tell you, hue is 0 to 360. Okay, so the value goes between 0 and 360, and then saturation and value are both 0 to 1. Okay, so and you can see that over here. So if we look at our values, and in fact it'll be easier if we grab just that one index. So just remember it's 0, 1, 2. So when we do that, it just prints just value. And look at the range that we have. So some of them are 1, some of them are 0.89. If we keep going up, there's a lot of 1s and 0.89s. Okay, there's some that are very low over here as well, 0.0062. Okay, so that could work. Now we might be accurate in saying that the 1 is probably our white bulbs, this is probably the ones that have color, and then these could be our base. Okay, so there's a good chance that we could use value. Okay, let's also have a look at lightness, so HSL, and then there we're grabbing L, which is lightness. Now here we get 0.8, 0.4, 0.8, 0.4, a whole bunch of those. We keep scrolling up and see what we get later on. We get 0.00625 as well. Okay, so there is clearly a big difference. There's some values that are really, really low, and then some values that are high. So we could use whichever one of these we want. HSL, HSV, doesn't matter. Okay, so I think hue, saturation, and value is normally more common, so I'm just going to go with that one, but you guys can use whichever you want. Okay. Now we don't even know. We're assuming that it's going to that those ones with low values are hitting the dark bulbs, but we need to double check that. So we're going to first confirm that. Okay. So let's store this. We're going to go HSV equals, and we're going to go col HSV, and just store the entire HSV value. Okay. Just so we can reference it later. So now I've stored that as a variable. And then what we're going to do is, we've asked it the question. We've asked each primitive, check for your color and tell me how bright it is. Okay, what is the value of your color? But now what we're going to do is to make a decision and say, well, if your value is less than a certain amount, then I want you to just do nothing. Okay, now to say do nothing, we don't really have to do that. We can leave that out. So what we're going to do is say if HSV, and then remember we want to grab just 2 because that is our value. So if HSV is greater than, and then we're going to set a threshold, then do something. But otherwise, if not, we're just going to do nothing. So we're not even going to put in an else with a pass or whatever statement, because you don't have to do that. So only if your value is greater than, now remember we had these large values. So 0.8 is obviously very bright. 0.4, that's quite a bit lower, but then suddenly there's this drop off to 0.00625. So I'm going to assume that these are our dark ones, but when we do check it later, we will make sure that we've set the right threshold and that this really is the difference between the base and the bulbs. So let's go in here and set maybe 0.1, okay? Because I doubt that any of the bulbs would have a value less than 0.1. Otherwise, it really is such a dark color. Like, why would that be? It's not like we're going to have a black light or something on this. Okay. So now what we want to do, inside of this block, we're saying it's only the bulbs then are going to successfully execute this block. So what do we want to do to the bulbs? Well, we want to find the center point. Now, one of the best ways to find the center point, because we could go through all the points and then have them kind of average and whatever, but a really easy way is to just grab the bounding box. Because a bounding box has a center. It knows, it's aware of a center point, okay? So we can even check the class. We go who.bounding box. And you'll see in here, we're able to grab our center. There's literally a handy function that says center. So if we can just calculate a bounding box, and in order to get that, it's a method of geometry. So on our geometry, we can just grab the bounding box. So let's do it on our primitive. So we're going to go to our original prim, because remember we're still inside this block, so we're looping on our prim. So we just tell the prim dot, and I'm just assuming here, but we should have the bounding box function. Okay, we did discuss this in the last lesson. So we go prim dot bounding box, and it wants no arguments, so it's just going to grab the bounding box. And let's store this in a thing. So I'm just going to call it bound equals, right? And then let me print the bound to make sure that it's actually done something. Okay. Now it may be a little bit hard to tell, but if our thing has worked here, we're checking the value. If that has worked correctly, then we should have at least like half the amount of printed values here than we did earlier, because it's not printing anything for the bases, only the bulbs. And just at a rough guess, it kind of looks like it has printed half of them. So I'm going to hope that it's worked nicely, but we will confirm later on. And you see our bound here, it has 6 values. So it's a min and a max vector. And from just those 6 values, it can then calculate everything. So min y, max y, min x, min whatever. It can calculate the center, the volume. It can calculate everything based on these 6 numbers, right? But what we want is the center point. So let's just say center equals, and then we're going to grab our bound dot center, because remember we're wanting to run that method on the actual bounding box itself. On the instance of that class, we want to run dot center to grab the center point. And we can do that. We can print that. So for every one of them, it's going to print a vector, which is the center point of where we want to place a bulb, hopefully. Okay. We're not going to make any assumptions, but at the moment we're working a little bit blind because there's no way for us to really visualize it. So let's just keep in mind and go and check it just now. Now actually we're at that stage where we can start testing it, because once we've got a center point, what we want to do is really basically just go and create a point at that location. Okay. Now remember when we spoke about geometry, we can create a bunch of points. Okay. If we look at under the creation tab of geometry, sorry, I think we're under this. Yeah, this is geometry. Okay, so under creation, we can create a point, or we can create points. Now, you may be in this case tempted to use point positions here like this. So create points and just feed it a whole list, because here we have a list of positions. Okay, but the problem with this, sorry. Every now and then I accidentally drag stuff on this and then it thinks I'm trying to type a function. So we've got this list of values here. So we could store those because it's printing them one at a time because we're inside of a loop. But what we could do is create a list over here. So let's say positions. We'd create an empty list. And as we loop through and we get that center point, then we would say positions dot append, and we'd append the center point. Okay, then afterwards we can check that we've got some positions. We've got a whole list of positions, and we'd do it would be geo, not geo1, because remember geo1 is our incoming geometry here. Instead we'd do this, where we'd go geo dot create points, and then we'd fill in our list of positions. Okay, and then it would go and create a point at every one of those positions, right? And this obviously seems to have done a good job, and we can even use this to now go and check and confirm that yes, it's at the center of the bulb, but there's only one point here. It has not created 2 points for every bulb. So I think that our base thing has worked nicely. Okay, so that's great, but the problem here is now setting color, because when we're inside of each primitive and we've got a reference to our single point in there, we have a color value. But then outside of that loop, we're creating all the points. So once we've created all the points, we now need to go and set all the colors. And so you would then need to go through and loop again through all the points we've just created in order to add individual color values to every single point. So rather than doing it this way, I've gone the other way, which is to create a single point one at a time inside the loop, because when we create that point, we can set its position and we can also set its color. Okay, so the drawback to that is obviously we're creating just a bunch of points and we're not able to actually work with them as we create each one. So I'm going to create, so I'm going to go geo.create point, not points, and we can't give that a center over here. It just creates a loose floating point, right? So that should result in the same thing. No, it hasn't created it. That's strange. How many points do we have here? Oh no, it has created them. Oh wait, hang on. Yeah, this is obvious. they're all sitting at the center, at the origin. All of them are there, right? Because we can't give it a center point. So we do need to move these. Now, we need to store it in a variable in order to work with it. And then we're going to say pt.set position. So remember I told you we can set attrib value, but that's a lot more work. There's a shortcut specifically for position because we know that you often need to move points around. So grabbing its position or setting position has just a handy function that is a shortcut. And we're going to set that to be equal to the center point. And now we should have the exact same result that we had earlier. Oh man, this keeps happening to me. If I hold spacebar, look, it just keeps spinning like this. It's insane. So unfortunately, I'm going to have to. It doesn't do it when I have this handle here. But when you hold spacebar, I don't know why it's doing it. It only started doing it in this scene. So anyway, that's a bit strange. Okay. So we have a point at the center of every bulb, but because we've created it this way inside the loop, we can add to this loop and go and have it set color. Okay. So let's try do that. Okay. So what we're going to do is just go and say, it's kind of obvious. We've got a reference to our point. So we're on point level. We want to go and just set the attrib value. So not just attrib value here, that's going to grab, but we want to set attrib value. So we go pt.set attrib value. And then we give it the name. So we want to set CD. And what do we want to set CD to? Well, we want to set it to the color value. We don't want to feed it the actual whole color. Okay. Color reference. We just want to give it the RGB values. Okay. So we're just going to do col_val. Okay. And it's going to error. Okay. So why is this erroring? We have a look at the error at the bottom here, and it says no attribute with this name exists. Okay. And it is even telling us the line like here where we're trying to set attrib value on a who.point. So, and I think it even specifies here line 16. Yeah, so you'll see. So we can even go and check our line number. And we say on line 16, this is where everything's going wrong. I mean, that was obvious because we only just added one line, but it is good to check. Okay. So what it's claiming is that we don't have color. We don't have a color, so it can't set color. And that is actually quite accurate because remember, we've got color on our incoming geometry, but that's on input 1. Input 0, which is our special input, that's our current geometry, and this point that we're trying to add it to was created on Geo, not Geo 1. Okay, so we do not have color initialized. So we have to go and initialize it. Now we can do that. We don't have to do it inside the loop, and in fact we shouldn't, because we don't want to do it every single time we loop. Even on empty geometry. Okay, I'm gonna go and disable this line just so that it's not broken anymore. Even on empty geometry, even before these points were created, we can set we can create an attribute. Attributes can be empty and have no points, but they just need to be initialized as something. Okay, so we're going to do that up here above this, before this whole loop, so that when we hit this point, we already have a color value, color attribute to write these values into. So we can go geo, so we want to operate obviously on our geometry, geo dot, and then remember, we did discuss it last time, on geometry level, there is an add attribute. So under attributes, you'll see that there is an add attrib function, which lets us specify a type, and then also the default value helps us specify what actual attribute type it is. Okay, so attrib type here is which level, so point, prim, vertex, or global, and then under the default value we get to the actual data type. Okay, so first thing we're going to do, so add attrib, and then we want to give it a type. So the type is a who.attrib type module, and within that module we're going to grab a property of point, because we want to add it at point level. Remember, we have only points here, so there's no point in adding it to prim level. Then the name is CD, and then the default value. Now we need to be very careful here. If we set it to 0, 0, 0, remember what's going to happen. Our color is going to be initialized as a vector, and it's not going to like that. So we want to go and say 0.0 for those. Okay. Now, as far as I know, you can actually just do 0.0 on one of the numbers, and then it will convert them all to a float. But I just, for consistency's sake, I prefer to have them all as floats so that I know that it has worked. Okay. And that's the only argument we're going to feed it. We're going to leave the others. And in fact, no, let's make this create local variable equals false, because I don't like those local variables being created for no reason. Now, this will work, and this will create color for us, but it is better practice if we also add a little bit of a check to just avoid errors, because if for some reason somehow we maybe later on change the system and we have some input geometry over here and it has color already, we do not want to try and reinitialize it because it will error. So it's better to put this inside of a block and say, because we can check if we have an attribute value. Okay, so find point attrib lets us check whether it exists or not, and if not, it returns none. And none can be used inside of none works like you know, when you've got true or false. If it returns none, then it also works like false. So we can use it like that. So in here we're going to say if, but actually we want to say if not, because if this does not exist, then do what's in the block. So if not, and then we're going to say geo.find point attrib, and then we just give it CD. So if you don't find a color point attribute, then go and create it. Now this is much better practice, because then no matter what changes later, we know that this is not going to error out. Okay, and once we have created that point, that color attribute, we should be able to go and set it on our points. Okay, and over here you should see, if I go and do that, you should be able to see all the different colors, and they should line up. If I go to this, let's take an area over here. We've got green, purple, 2 whites and a red. If I go now here, okay, it is harder to see because they're you know, they don't have a distance to them, but let's increase the size of these sprites. And anyway, you can see here there was a green one over there, so there's a green one there, purple, so there's purple, and so on. Okay, so it clearly has worked. Okay, let's set this back. Okay, so now we have something to work with, and the only last thing I'm going to do over here is just create an out, because you should always have an out, especially later when we're going to want to reference this with some code. So the next step is us now actually using these points that we've created and actually going and running the copy of some point lights to those points and setting their color and setting their parameters and doing all of that. Okay, which we're not going to do at SOP level, because we want to do that only once, not every time it cooks. So we're going to be doing it through the Python source editor. Okay, all right, so I'll catch up with you all in the next lesson. Try to do this if you can, you know, several times. Make sure you understand it up to this point, because it is only going to get more complicated from this point. And you know, I hope that you're able to actually follow along, but also to do it yourself before we even get there. Whether you're getting it right or wrong doesn't really matter. It's that struggling with it, grappling with it, challenging yourself, and then coming and seeing what the right answer is. You learn much more than just watching a video and going, oh, that's cool, and then next time you get to work or whatever, or you're on project, I guarantee you won't remember it because you haven't put it into actual memory if you don't do it yourself. Okay. All right, so thank you everyone, and I'll see you in the next lesson where we'll finish this off.